If you are taking a class in quantum mechanics, you are very likely to run across this problem where Dirac delta function is a function of one variable, then it's translated into function of another variable. What makes it confusing is that not only these variables change, but the differential over which it's integrated is also changed. For instance, if we have delta a of x and differential of a of x, and we do it minus infinity to infinity, it's straightforward. This is equal to 1. But the confusion comes when you write down minus infinity to infinity, delta a of x dx. Now, what we have to do, we have to find a relationship between dx and d of ax so we can get back to this. So let's, this one is, this part is pretty easy where we say d of a of x is equal to a d of x. So what we want to do, we want to convert this into that. And so we replace dx. Dx is equal to, this is just a manipulation of this, 1 over a d of a of x. So what we do, we plug into this expression here into this integral, this expression here for dx. So this here will become minus infinity to infinity 1 over a delta a of x and d of ax, and which is equal to 1. And then the further confusion comes where we want to represent this also in terms of delta x. And we know that this one is also can be thought of as a dummy variable of integration. So we'd say minus infinity, infinity, 1 over a delta. So let's say we replace ax by, we can replace ax by x prime, or we can replace it by y, or we can replace it by phi, or we can replace by z, or we can replace by t. We can replace it by anything we like. So let's say replace it with phi. That's because that's the one used when you generalize this Dirac delta function as a function of another function. So we will have delta phi and d of phi, which is equal to 1. And we could also write this as just minus infinity to infinity 1 over a delta of x dx equal to 1, and that's equal to 1 over a delta x dx minus infinity to infinity. So this one this is what we set out to prove, that delta of ax equal to delta of 1 over a delta x. Now suppose a is minus. If a is minus, then what will happen is you will get minus a here, where a is still some real number that's positive. So you have minus a, then these limits of integration also change. So then this becomes delta of a of x equal to 1 over minus a of delta x. And minus and minus, that makes a plus, and then that's the reason this becomes an absolute value. Well, I'll make another video where we will go through where this is a is a real number, but it's less than 0. Sometimes it gets very confusing when you are mixing the negative sign and then you assuming a is negative. You have negatives and making positive. That's very confusing. So for the time being, we just leave it at that when a is greater than 0.